All right, day 2, we're going to actually be finding the volume of prisms and cylinders. Cylinders kind of lie in the same category as prisms because they have two parallel congruent bases. Okay, so that's why we kind of put cylinders and prisms together. And then next section, we're actually going to put pyramids and cones together. So first, okay, I know it seems kind of silly, but they do have a separate conjecture for a rectangular prism, but it's the same as all the others. Okay, so for the first one, rectangular prism volume conjecture, if capital B is the area of the base, okay, so our base of a right rectangular prism, and H is the height, then the formula for the volume is area of the base, capital B, times the height. Now I know a lot of you know it as length times width times height. Okay, but we do not really use that anymore. Yes, in order to find the area of the base, we take length times width, and then obviously we multiply by the height, but we use this so that we can use it for other prisms as well. All right, so for the right prism cylinder volume conjecture, kind of a lot going on here. But remember the other day we talked right versus oblique, okay? And we're going to find out that we solve them the same way, but again, they have two separate conjectures for us. So again, if B is the area of the base of a right prism or cylinder, and H is the height, then the formula is going to be area of the base times the height. So this goes back to our chapter 8 unit on area because we need to know how to find the area of certain polygons, whatever the base is. Okay, so for this case, in this picture, I need to find the area of this pentagon first, and then I would multiply by the height of the solid. All right, and now we're getting to our oblique prism cylinder volume conjecture. Okay, for this one, the volume of an oblique prism or cylinder is the same as the volume of a right prism or cylinder that has the same base and the same height. Okay, so if we were to put this upright, okay, we'd solve it the exact same way. So I'd take the area of the base and I'd multiply it by the height. All right, last but not least, okay, prism cylinder volume conjecture. The volume of a prism or a cylinder is the area of the base multiplied by the height. Okay, so for a case of a cylinder, the base is a circle, so we also need to know our circle area conjecture, how to find the area of a circle, and we'd multiply that by the height. So pretty simple if we felt good about chapter 8 with our area, because all for prisms and cylinders, we just have to find the area of the base and then multiply it by the height. And remember, the height is always the one that's in between the two bases. Okay, so it would not be this distance here. Okay, it's always the area between the two bases. All right, we're going to get started on kind of a tough one to get started, but here we have a trapezoidal prism, so that is key that our base is a trapezoid. Okay, this is not our base, that rectangle. Yes, it's sitting there, but that's not the base. The base is a trapezoid because we have two of them here. We have this one and the one in the back. So if you remember, let's first write down the volume formula. Volume equals area of the base times the height. Please write this down. It seems silly, but it's really going to help you out. Then the area of the base, I'm going to replace that with the area formula for a trapezoid. Okay, and if you remember, it was 1/2 base 1 plus base 2 times the height. And then we're also, I should capitalize this H for capital H for our solids, times the height of the solid. Okay, so all I did was replace B with the area of a trapezoid formula. Okay, and then they gave us some key things to plug in. Okay, they gave us the two bases of our trapezoid, which are 4 and 8. They gave us the height of the trapezoid, which is 5. And then they gave us the height of the solid, which is 10. Okay, so then when we can plug all that right into our calculator, as shown. Okay, so I just plugged it all in, 1/2 parentheses 4 plus 8 parentheses times 5 times 10, and end up with a volume of 300, and our units are centimeters cubed. When we're talking volume, we cube them. Area was our last unit, and we squared it, and now we cube it for volume. All right, the next one we have an oblique cylinder, and remember we're going to solve oblique shapes the exact same way. So I'm first going to jot down the volume formula. Volume equals area of the base times height of the shape. And since we have a cylinder, my base is a circle. So I'm going to replace B with r squared pi, and then times that by the height of the oblique cylinder. And then we plug in what we know. We know the radius is 6, and we know the height of the oblique cylinder is 7, not 9. Okay, 9 is not the height there. Remember, height is always perpendicular to the bases. And then if we plug that in, I'm going to try, I'll keep it in terms of pi, and I'll keep it around to the nearest hundredth. So if we do 6 squared, I get 36 pi, 36 pi, and then I'm timesing by my 7, so I'm going to take 36 times 7, and I get 252 pi. And we're talking inches cubed, so this would be an exact answer, but if you are approximating it, you would get 791.68 inches cubed. Okay, so either answer, since it didn't specify, make sure you always read the directions. All right, here's another one. We have a triangular prism. This one, people like to get confused because they like to think of that rectangle being the base. But remember, in a prism, we have two bases. In this case, the two triangles are our bases here. Okay, so let's write down the volume formula for a prism. Volume equals area of the base times the height. Since my base is a triangle, okay, I'm going to assume this is a right because I have a Pythagorean triple here, so I can actually confirm that it is a right triangle, so it makes things a little easier. But I'm going to replace B with 1/2 times B times H times the height. So this is the area formula for a triangle. So I plug in what I know. In the triangle, I know the base is 4 and the height is 3. And I know the height of the prism is 11. And then I'm going to plug all that into my calculator. So I end up with 1/2 times 4 times 3 times 11. So I get 66 centimeters cubed.